Is it visible? Whether slides are visible? Yes. Okay. Fine. So, insecticide resistance, mainly I will be discussing about three different strategies proposed by, the first two was proposed by scientists, and the third one is proposed by FAO. The FAO resistant management strategies are the newer one. So, if you check all this, it talks almost the same language. It doesn't differ much, but they discuss it in their own manner. So that's the thing. But the crux remains the same with all these three management strategies. So the first I will see the definition of insecticide resistance management, or IRM. Insecticide resistance management seeks to slow down, prevent, or reverse the development of resistance in insect pests. I will repeat. The intention of a resistance management program is to slow down the development of resistance, to prevent the development of resistance, and if the resistance has already occurred, our intention is to reverse it. That means make the insect more susceptible. We can do it because it is reversible. Resistance is not a permanent feature. If we withdraw the selection pressure, that means if we stop the spraying of that particular insecticide for a while, the insect, as the selection pressure is decreased, the insect will become susceptible again. So reversing is possible. We can slow down. We can adopt several strategies so that we can slow down the development of resistance. And second one is preventing the development of resistance is a tough task because we can slow down, but preventing it is a difficult task, I feel, because uh, it's not that easy to prevent insect development of, because insects has the inherent ability to develop resistance to a particular pesticide. And whatever be the strategy, we should make sure that the pesticide dose at what we use, it should not discriminate between the susceptible homozygotes and the resistant homozygote. That means that whenever we are using a pesticide, if that pesticide kills only the susceptible homozygotes and the resistant homozygous individuals, if it survive, it lead to the development of resistance quickly. So our intention should be to prevent that discrimination, prevent the selection of resistant homozygous individuals. So this is what we should do. That means we should uh, prevent prevent the selection of a resistant homozygous individual. Okay. Then insecticide resistance management can be, I told you, there are three different, uh, what to say, strategies proposed by three different persons. One is, two are from scientists and other one is from FAO. We will discuss it. The first resistance management strategy is given by Giorgio. Actually, Giorgio is a scientist who worked immensely on insecticide resistance. He proposed it way back in 1983. That means about half a century back. He proposed it by three strategies. One is management by moderation, second is management by saturation, and the third one is management by multiple attack. So we'll usually tell it as moderation, saturation, and multiple attack. Moderation means that we can reduce the we should reduce the dose of the chemical, reduce the dose of the pesticide used, reduce the pesticide load. That is management by moderation. In the there is a second management strategy. You can know how moderation strategy will work. And in the management, saturation means that increase the dose so that all homozygous susceptible as well as homozygous resistant individuals will get killed. In moderation, we reduce the pesticide load. In more, saturation, we will increase the dose so that whatever be the susceptible homozygous individuals and resistant homozygous all get killed. And the third is multiple attack means rotating pesticide, mixing pesticides with different mode of action, mixing pesticide which is synergist, all includes management by multiple attack. So moderation means reducing the pesticide load. Saturation means increase the dose. Multiple attack means rotating, mixing, or using synergies. So in a resistance management strategy, we can use a single strategy or combine several strategies and adopt it to reduce, slow, prevent, or reverse the evolution of resistance. So this is Georgia has given only three strategies, but later in 1990, again it is about four, 4 decades old. It is given by Rausch and Daly. Richard T. Rausch he has written an excellent book on pesticide resistance. That book, Pesticide Resistance in Arthropods, that is co-authored by Tabashnik, Rausch and Tabashnik. Those two are the authors of that book, and he has given basically strategies which is divided into two categories. The first one is reduce the fitness of resistant individuals when the pesticide is applied. See, reduce the fitness of resistant individuals when the insecticide is applied. And the second one is reduce the total amount of selection pressure applied. So he has divided the resistant management strategies into two. But first is reduce the fitness of resistant individuals. Second, reduce the total amount of selection pressure. So first we will discuss about reducing the fitness of resistant individuals. The among these reducing the fitness of resistant individuals, first we can go for increasing the dose. That means what we had discussed, saturation, management by saturation as given by Giorgio. Increasing the dose to kill heterozygotes and resistant homozygotes, and reduce use a dose which confer lower level of resistance. We will discuss it how it happens. And whenever we are using a pesticide, ensure that the most susceptible stage of the insect is present in the field. And don't spray the crop when the pest is at the tolerant stage. Say, when the pest is at the pupal stage, it is more tolerant to pesticide. So when we spray pesticide when the pest is in the pupal stage, it won't have any effect. And use synergies to suppress the detoxification mechanism that we will discuss. Then mix pesticides with different mode of action and metabolism. And reducing the total amount of selection pressure, here we can go for decreasing the concentration of pesticide. Reduce the number of pesticide application, that means the frequency of pesticide application can be reduced. And use pesticide with short residual activity and avoid slow release formulation. The intention is to reduce the persistence of the pesticide. If the pesticide is persistent in the crop, that lead to development of faster development of pesticide resistance. And do not spray all habitats. Go for spot application, or you might have studied about refugia strategy in the case of BT cotton. We will leave an area of BT cotton with the non-BT cotton. So that is refugia strategy. So that we can go for. Then we can rotate the pesticide. We'll come to it one by one. Increase the dose to kill heterozygotes or resistant homozygotes. This resistant this strategy will work if the frequency of resistance is very low. That means the number of individuals with resistant gene is low. That means so that we can kill the entire resistant genotypes with a slight increase in the dose. If the resistance has evolved in large number of individuals in a population, then this strategy may not work. We have to increase the dose to several levels. It may not be a viable strategy. So this works well when the pest has just evolved resistance. And otherwise, if the resistance has evolved and it is in higher order, the strategy will not work. And this we intend to kill all the resistant homozygote, and we have to ensure that the entire population is treated. We won't leave any small area untreated, because otherwise the resistant homozygotes will survive, and again the resistance will persist. But the disadvantage, as you can understand, is if you are increasing the dose, the residue in the produce will be extremely high. So the environmental and economic cost will be higher. Pesticide residue will be high. The farmers has to go for higher volume of pesticide. His cost will increase. Another thing is that if you are increasing the dose, it may leave persistent residues in the crop. That means if you are using the recommended dose is 2 ml per liter, the pesticide may persist for about 3 to 5 days. If you are increasing the dose uh, to 4 ml per liter, the pesticide may persist for another 8 or 10 days. So what this means that if you are increasing the dose, the residue will persist for a longer period. And strategy to manage pesticide resistance is that we will allow the migration of susceptible population from neighboring area. Here, what this is what we intend to do. We will kill all the resistant homozygous individuals. So from the neighboring area, the susceptible individuals from which wild population which are not exposed to pesticide will migrate to our area. They breed in our field, so that they again the population will become susceptible to the pesticide. But if you are using a persistent pesticide, what will happen is that when the susceptible individual migrate to our field, once it settles over the treated crop, it will instantaneously kill, because we are using a high dose. So it will kill all the incoming susceptible population. So this is one disadvantage, and the residue problem will be high. The cost, there will be an increase in the cost. So as I already told, this is strategy will work in the early stages when resistance has not grown into a higher magnitude, and where we can uniformly apply the pesticide and the dose can be perfectly controlled. So here it's nothing but increase the dose so that all the resistant homozygous individuals can be killed. Coming to the next, use compounds that confer lower level of resistance. That means even within a pesticide group. Here I have given an example of dieldrin and lindane. Among this, both belongs to the cyclodine group. Among dieldrin and lindane, if you are using dieldrin, insect develops resistance pretty quickly. But against lindane, the development is pretty slow. So if you are using a cyclodine pesticide, go for lindane because it develops resistance pretty slowly. And in the case of OP insecticides, pyrimicarb and dimethonosmethane. Pyrimicarb is a carbamate. It's not an OP insecticide, but both act on acetylcholinesterase inhibitor. But the selection for resistance is low with pyrimicarb, while for dimethonosmethane it is pretty fast. So try to use those pesticides where development of resistance is lower, and treat the most vulnerable stage of the insect. That means I will give an example. Again, I will quote the example of Dr. Kranti. What he, one of his paper, he studied the resistance in different larval instars of Helicorpa. So what he observed was the early stage neonate larvae of Helicoverpa are extremely susceptible to insects, insecticides. But the later stage larvae, the bigger larvae which have well developed fat body, are showing resistance towards pesticide. So that's why he developed a IPM strategy in cotton, wherein he advised the farmers to go for pheromone, Helicorba pheromone traps, and he timed the pesticide spray based on the trap catch. So once Helicopa adults are trapped in the pheromone trap, he advised farmers to go for a pesticide spray on fourth or fifth day. That means the Helicopa will lay eggs. Once there is a catch in the pheromone trap, it means that there is insects. There, Helicopa adults are there in the field, and once the adults lay eggs on the crop, it will take 3 days for hatching. So, if the farmer is spraying on fourth and fifth day, the larvae will be neonates and it will be easily killed, even if the insect is resistant at the later stage. So, a resistant population as well as the susceptible population of Helicobacter lamigera got killed till it is 3 days old. But once it crosses that first instar, it will start exhibiting resistance. So, whenever we are going for a spray, ensure that the pest is present at the susceptible stage. And coming to the next strategy, reducing the fitness, that is to use synergies to suppress detoxification mechanism. We have discussed about synergies. Synergies block the enzyme detoxification enzymes. So synergies can be used when enzymes are detoxification enzymes are the major mechanism of insecticide resistance. So we can use, if estrase is there, we can use a synergist such as PBO, piperonal butoxide, which can block esterase enzyme. So that is one, but synergies cannot be used when target site insensitivity is the mechanism of resistance, because synergies cannot change the mutation as a point mutation happened in a gene. Then again, for reducing the fitness, we can go for pesticide mixtures. That is the one most commonly used. We can use a mixture with different mode of action. Usually, in our country, we have pesticides mixtures mostly with organophosphates and synthetic pyrethroid. Organophosphates are acetylcholinesterase inhibitors, while synthetic pyrethroids are sodium channel modulators. So we had that as two different mode of action. So the insects may not develop resistance to two pesticides with different mode of action. It's not that easy. So we can use pesticide mixtures to manage insecticide resistance. Coming to the next set of category, reduce the decrease the selection pressure. That is reduce the total amount of selection pressure. So this includes first decrease the dose that kills the most but not all the susceptible. That means whenever this strategy suggests that whenever there is a pesticide resistance, reduce the dose. This dose will allow the survival of a few susceptible individuals, so that the resistant individuals can breed with the susceptible individuals and resistance can be diluted. That is the theoretical strategy behind it, but practically it's not a viable strategy. So here I will repeat, what we intend to do is to reduce the dose so that some susceptible individuals will survive and it will breed with the resistant individuals and reduce the resistance frequency. And reduce the number of pesticide spray. That is one strategy we usually advise. We advise the farmers to go for a pesticide holiday and all. Otherwise, we can go for a higher ETL. If the ETL is higher, frequent application of pesticides may not be needed. So these are strategies to reduce the pesticide application and avoid pesticides which have high persistent, high residual toxicity. If a pesticide has high persistence, it means it's just like repeated applications of a pesticide. I told you an example wherein if the dose is increased, persistence is increased. So there are certain persistent pesticide. Pyrethroids, one advantage is that it is extremely non-persistent. But the organochlorines, it is extremely persistent. So development of resistance will be more for persistent pesticides such as organochlorines. So try to avoid the use of persistent pesticide. If a persistent pesticide is used, insect will be exposed to the pesticide continuously for a longer time. So that increases the selection pressure. And do not spray all habitats, give a refuge here. The intention is that if you don't spray all the area, the susceptible individuals can survive in the unsprayed habitat and it can breed with the resistant individuals, and the resistance frequency can be decreased. Another strategy is to go for spot application that you may know. The pest may be present only in a small area and try to spray only in that small area and not spray on the entire area so that a portion of the pest is not exposed to pesticide. So that susceptible individuals in that unsprayed area will survive and reduce the development chances of development of resistance. And rotate pesticide and rotate pesticides, we have three strategies: rotations, sequential introduction, and mosaics. I will repeat it again. We can rotate it, we can go for sequential introduction, or go for mosaics. Rotation or short, rotation is a short term strategy. That means that, say, if you have a rice crop, and if there is stem borer and leaf folder infestation in the crop, you go for a chlorantraniliprole spray, and after say about 25 to 30 days, again there is a reinfestation of stem borer and leaf folder. Don't go for flubendiamide or chlorantraniliprole because both are diamide insecticide. Go for an OP, acephate, or fipronil. Both are having different mode of action. It is effective against stem borer and leaf folder. So that is short term rotation. And long term rotation is sequential introduction. Say that can be adopted by companies if the company has different pesticides in the pipeline. One pesticide, say pesticide A, it is having one particular mode of action, and pesticide B having another particular mode of action. So the company will introduce pesticide A this year, and after 2 years, it will introduce pesticide B. So by 2 years, the pest may slowly develop resistant towards that particular pesticide A. So by the third year, company will introduce pesticide B, that is sequential introduction, so which is having a different mode of action. So the chances of development of resistance is lowered. That is again a rotation, but it is sequential introduction. And next is mosaics or rotation across space. That means if you have 10 acre of rice, 3 acres you will spray chlorantraniliprole, 3 acres you will go for spraying with fipronil, 3 acres you will go for spraying with acephate. Understood? Did you are you getting the three concept: rotation, that is a short term strategy, sequential introduction, and mosaics? Are you clear? Yes. Okay. But rotations are more effective than mosaics. Mosaics, as you all know, it is very difficult to practice in the field. Sequential introduction normally a farmer cannot do. So a companies should do that. So we have discussed about the management strategies proposed by scientists. First one was by Georgiou, second one was Rausch and Darley. And now I came across this FAO insecticide resistance management strategy last year only. I was not knowing about this FAO management strategies. So it is a huge document. I have called out only the major points in that. If you go through that, you can understand it is a bit or elaborate IPM strategy. And the major concept FAO is proposing is that insecticide resistance should not be a standalone thing. It should be part of IPM. So that is what the crux of FAO IRM strategy. It should be a part of IPM. It should not be standalone. And we have to adopt IRM strategies as and when the pesticide is introduced in the market. We should not wait for the resistance to develop and to start resistance management strategy. We should take up resistance management strategy as and when a pesticide is newly introduced in the market. So that is the second thing FAO says that. And the third thing FAO says that focus on the pest and not on the crop. I told you yesterday, we have Helicobacter armigera in Maharashtra, where in the first crop it attacks cotton, second crop it attacks, that is in the Rabi it attacks chickpea, and in the third crop, summer crop, it attacks tomato. So we have usually what is whenever you go for a resistance management strategy in our country, you can see that we have an insecticide resistance management strategy for cotton, but that is wrong because the helicobacter which is attacking the cotton, the same population is attacking chickpea as well as tomato. So FAO says that focus on the pest, not on the crop. So resistance management, if you are going for resistance management, it should be resistance management for Helicobacter parmigiana, not for resistance management in insecticide resistance management in cotton. I think that sounds more logic. So that is what FAO says. And consider adjacent host crops. So remember, whenever a farmer is going for cotton in the Kharif season, in the adjacent plot, other farmers may be going for soybean, another farmer may be going for pulses. It can be green gram, it can be PGNB. So this pulses as well as cotton is a host crop for Helicobacter pharyngica. And again, if you are considering resistance management, insecticide resistance management in cotton alone, it won't work. So that's why it again FAO again repeats that we should consider focus on the pest and focus on adjacent crops also. Don't focus on cotton alone. We may feel that cotton is the most economic high value crop, so we should try our efforts on cotton resistance management in cotton. No, we have to consider adjacent crops also, and we should try to protect beneficial organism. See, this is what the FAO says. We should consider resistance management as a part of IPM. So beneficial organisms should be protected and try all the alternate non-chemical pest management measures so that resistance development is delayed. Again, a part of IPM. Use more than one class of pesticides, that is rotation, mixtures, etc. And another thing FAO says is that consider all treatments made during the year. So FAO says that if certain insects, I can suggest only an insect such as root grub in our country, wherein a farmer may be drenching chlorpyrifos in the soil for managing the soil-borne grubs. And during May, June, when the adult emergence happens, again the farmer may be going for a spray of chlorpyrifos. So that means the larvae as well as the adults are exposed to the same pesticide, though at different time interval. That means the whole population is exposed to same pesticide, though at different time intervals. So that we have to consider. And again, I will go back to Helicobacter. So there we have 3 seasons, 3 different crops, but a single pest, Helicobacter. So we have to take the entire year, which are all the pesticides used in cotton, which are all the pesticides used in chickpea, which are all the pesticides used in tomato, and we should have a management strategy considering the pesticide use throughout the year. We should not repeat the pesticide which is used in cotton in the chickpea or in tomato. We should rotate it. And apply only recommended pesticide application date. That's usual. Involve stakeholders. That means we should take farmers into confidence. If farmers are not happy about it, if farmers are not willing to adopt an IRM strategy, it won't work. And once we are implementing a resistance management program, we should go for midterm evaluation of this resistance management program, whether our strategy is working. How we can go for, we can continuously monitor the frequency of resistant individuals. So every season or every year, go for a diagnostic dose bioassay whether the resistance frequency is increasing or decreasing. If it is decreasing, means yes, our strategy is working. If it is increasing, that means more individuals are developing resistance. That means we have to refine our resistance management program. And then go for rotations of pesticides, that you know, rotation with pesticides with different mode of action. That's what it says, unrelated pesticides. And again, FAO says that though mixtures can be recommended, use mixtures with caution. I have, I don't usually recommend personally. That's my personal belief. I don't say that it is a perfect thing to do. I don't usually recommend pesticide mixtures to farmers because I am not convinced about the effectiveness of a pesticide. Though yes, in certain situations, say when in rice, sometimes I also recommend when we have a infestation of BPH as well as leaf folder at the late stage of rice crop. Sometimes we may get heavy incidence of BPH as well as leaf folder. In that scenario, nowadays whatever pesticides we have is either effective against sucking pests, say imidacloprid or thiamethoxam, or we have diamides which are effective only against lepidopterans. In that case, we can go for pesticide mixes. Now we have a for combination chlorantraniliprole plus thiamethoxam. It's available in the trade name Virtaco and Volume Flexi. Virtaco is a granule formulation which can be broadcasted just like Fertera, and Volume Flexi is a sprayable formulation. Syngenta is marketing it. So unless and until the situation demands it, don't go for using pesticide mixtures because incorrect usage of mixtures can increase the chance of resistance. So whenever we are using a pesticide mixture, we should ensure that the pest has not evolved resistance to any of the pesticide in that pesticide mixture. Say we have an OP as well as a synthetic pyrethroid in a particular mixture, and if we are using that particular pesticide mixture in the field, we should ensure that the pest does not have any resistance to it, either an OP insecticide or to a synthetic pyrethroid. If the pest has evolved resistance to at least for OP, again it will increase the resistance problem. And even if the pesticides are mixed together and the mixture pesticide mixture is used, it should be at the recommended application rates. That means if we have a combination of Ecalex and cypermethrin, quinalphos and cypermethrin. Quinalphos we usually recommend it at the rate of 0.05 percentage, and cypermethrin we usually recommend at the rate of 0.001 percentage. And we are mixing quinalphos and cypermethrin. And when we are using the mixture, pesticide mixture, that combination that is sprayed again should be having the same dose. Quinalphos at 0.05 and cypermethrin at 0.001. That we should ensure. And both the active ingredients should have same residual activity. If one insecticide in the mixture is having high residual or persistence, high residual activity of high persistence, it's not an ideal strategy to use because again it will increase the selection pressure. And then we can go for synergies, but use of synergies will be, it should be with caution because synergies work only if the resistance is due to increased enzyme activity. If it is due to target site insensitivity, synergies may not work. See, the other management strategies proposed by Rausch and Daly and Georgiou, both are the strategies are proposed when molecular biology has not advanced this much. So at that time, target site insensitivity was not a major mechanism of resistance. So that's why nowadays scientists exercise caution in the use of synergies. And then we can use some rotate with non-specific products, pesticides, soaps, oils. You might have studied about horticulture mineral oil. Hasina madam might have taught you. Very effective against mites as well as sucking pests. It's not non-specific in nature. It is a physical poison. So we can go for that. And whenever we are going for a pesticide spray, apply them with extreme care and monitor problematic pests such as mites, aphids, whiteflies, spodoptera, helicobacter, etc. Because these pests has the ability to develop resistance pretty quickly compared to other insects. So this is pesticide resistance management. Any doubts and completing the resistance portion? Abhishek, what is the normal cropping pattern in your area in Tumkur? Ragi and maize. Ragi in the first crop and maize in the second crop. Is it? Yes. So then you may not have ragi. You won't have much problem of pesticide. Maize. Whether fall armyworm is a problem this year? Yes. There are reports that the fall armyworm is migrating from maize to ragi. I read a report last week. Yes or no? Have you read anything regarding that? Tickable procurement. Is it okay? Is it migrating from maize to ragi? Whether that report is correct? Yes. Okay. Because here we have rice. We are watching the situation. Whether if some says that it can attack rice also, then only creates a problem over here. Okay, fine. So tomorrow onwards, tomorrow you won't be taking class because TP presentation will be going on. Day after tomorrow. By that time, one thing you should do is have you got some material which I have passed on to Rahul regarding the laboratory techniques course with respect to chromatography, HPLC, gas chromatography, etc. Do you remember? It was way back in April, 5 months back. Do you remember that, Rahul? Yes. So circulate it again. I will add in that in the module because in residue, first we will consider some theoretical aspects of pesticide residue. Next, we will go for residue analysis and instrumentation. 3 to 4 classes we may need. Okay, fine. Thank you. If you don't have anything with respect to resistance, do you need any further clarification? Okay, then fine.